Today, I'm going to be beginning a video about area. Specifically, the area of a polygon is the amount of surface it covers or the number of unit squares contained within it. Many students confuse different labels related to both area or perimeter or volume, and so we're going to first begin to discuss what types of ways we can measure things. When you measure in length, you measure a linear unit. So for example, this line is 8 inches long. Now that's very different than when you measure an area. Area is measured in square units. This rectangle has an area of 8 square inches or 8 inches squared. Now that's very different than the linear measurement we were just talking about. They're both 8 inches, but 8 square inches indicates that it's 8 separate squares that are each 1 inch by 1 inch. Volume, however, is measured in cubic units. So if you look at what 8 cubic units look like, it's 8 separate cubes. So when you're comparing 8 inches cubed, 8 square inches or 8 inches squared, or just 8 regular inches, you should definitely realize that they're all very, very different measures. Now, our goal is to find out how area works. We want to kind of delve into what this definition tells us. It tells us to find area, we need to know how many what the surface it covers, or how many unit squares are contained within it. One way to find area is simply to count the squares. If you happen to be working with a figure that's on graph paper, you could simply count the squares. However, in anything larger than 3 by 3, it's inefficient to just count each of those individual squares. To count all 60 of these would take a while. What we've learned is when you're dealing with a rectangle, if you've got a length of 5, as you do in this situation, and a width of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, rather than counting 12 rows of 5 or 5 rows of 12, we can just multiply 5 times 12. And since 5 times 12 equals 60, it tells us that there are 60 squares here. Now, to go further, because we're dealing with squares, our answer would be 60 units squared. That's the way that we label our answer, is 60 units squared, because we're indicating that it doesn't mean a length of 60, it means 60 square units. Now, I labeled it in units squared because this measurement is not defined. In the future, if it says units, you would just use units. If it says centimeters, you'd use centimeters. So we're going to be working with just units because I'm working with the same size craft paper today. But we're going to talk specifically when working with area that we have a formula protocol that I'd like you to use. That formula protocol is very clear. You identify what polygon you're looking at so that you can use the appropriate formula. You then write the appropriate formula, substitute values for those variables, solve, and then label your answer in square units. And to kind of help make this process work a little smoother, I've got these same little squares I'm going to use for writing out my work, and then I'm going to have visual aids that are all using graph paper. So this first one is a simple one because we're just doing rectangle area. And so my first goal will be to identify what type of figure is this. It's clearly a rectangle. Now, I know that the formula for a rectangle is length times width. And we write the variables next to each other without the operation sign because that's the most efficient way to write it. In this case, I will be identifying my length and my width, much like I'll be identifying my base and my height by color coding them. So I will always make my bases pink and my heights blue to make it easier. You may recall in class that we've talked about how the base and the height always meet at a right angle, and that's something you've known for a long time because anytime you've found the area of a rectangle, you've used the formula length times width. Now, if we use the same formula we use for a parallelogram, which is base times height, you'll note it's the exact same formula. You're simply multiplying those dimensions. So for our purposes, we do know that the length is 8 and our width is 5. And so I'm going to go ahead and write those numbers to replace them. Since now I've replaced my variables with numbers, I do need a multiplication sign to indicate that I'm multiplying. Obviously, I know that 8 times 5 is 40. And then because my label is units, I'm going to write my answer as 40 units squared. Now that was probably the easiest one for us to do because we're so familiar with how to find the area of rectangles. We're going to now move on to parallelograms. Now in this situation, we have a parallelogram and it has more labels than what we need. So it's really important for us to go back to our notes on identifying the base and the height of a figure. So in this situation, I've got lots of labels, but again, I've color-coded it to make it a little easier, and then we'll review this vocabulary. The base is always on the edge. So my possible bases are these two pink lines or these two green lines. Now my height has to meet the base at a right angle, and the only bases that meet with the height of 5 is this one, the 10, and this one that's 10. So I'm going to choose to use one of these bases since they're identical. A parallelogram has congruent opposite sides. I'm going to go ahead and identify this as a parallelogram. And I know the formula for finding the area of a parallelogram is base times height. And my base is 10, and my height meets it at a right angle and is 5. 10 times 5 is 50, and my label's units, so my answer is 50 units squared. Many people realize, well, does it really matter which one is the base and which one is the height if you're simply multiplying them? No, if you go back to your rectangle, it really doesn't matter. However, some of our formulas, the base and the height aren't just multiplied. So it's important for us to understand which is the base and which is the height by following these rules. The base is always on the edge, and the height always meets the base at a right angle. It's true of parallelograms, it's true of rectangles, and it's true of all figures that we use formulas. So we now have a triangle. Now the triangle formula is different. The triangle formula uses half as part of it, of the formula, and that can be a little challenging for some of our students. So it's important to take this one step at a time. We clearly know that this is a triangle. And I will share with you the formula for finding area of a triangle is 1/2 the base times the height. Now some people tend to multiply the base and the height and then multiply that by 1/2 or even divide that total divided by 2. I like to do 1/2 base times height because it allows me to use my commutative and associative properties whenever necessary. So now I've got to identify which is the base and which is the height. I've obviously helped out quite a bit by color coding it, but we're going to go by the same rules. The base is always on the edge. The height always meets the base at a right angle. So truly, if I'd had a measurement at a right angle with one of these green lines, I could have used the green line as my base. But since my only labeled measure that is perpendicular or at a right angle to my base is the 8, I'm going to have to go with my base of 10 and my height of 8. So I'm going to substitute these values, and now my formula is 1/2 times 10 times 8. And at this point, because of the commutative property, I can do 1/2 of 10 and multiply that by 8. I could do 1/2 of 8 and multiply that by 10. Or I could use my associative property and do 10 times 8 first and then multiply that by 1/2. No matter how I go about that, I'm going to get the same answer, which is 40. And looking at my label here, it's in units. So I'm going to write 40 units squared. Now, this triangle is clearly a triangle that is acute. I can do the same exact formula with this triangle that looks very, very different. It's going to be different numbers, and it's going to give me a different answer, but it does use the same formula because all triangles, those same properties of having 3 sides, allow us to use this formula. So just like before, this is a triangle. My formula would be 1/2 the base times the height. And at this point, I'm going to use my 6 as my base and my height as my 8. And since I know half of 6 is 3, 3 times 8 is 24, my area will be 24 units squared. One of the more complex formulas that we use in 6th grade is the formula for finding the area of a trapezoid. And I've purposely labeled this trapezoid with extra measures to make sure that we take extra care in only using the parts that we need. So again, the first thing we're going to do is we're going to identify the figure, and this is clearly a trapezoid. Now the formula for a trapezoid is complex. It is 1/2 the height multiplied by the sum of base 1 and base 2. What you should know is that with a trapezoid, it does have two bases that are parallel to each other, but in order to be a trapezoid, they're never congruent. So in this formula, we actually have to find the sum of those two bases. It doesn't matter whether you make the top one base 1 or the bottom one base 1. It just matters that when you use them in the formula, you include both bases. So my height is the only number, this 6 is the only item that meets my bases at a right angle. So I'm going to go ahead and substitute the height for 6. And these parentheses are really important because they do indicate that I'm adding those two bases first before I do anything else. And so I know 4 plus 12 is 16. And now I've got a formula that looks a lot like my triangle, where I can go ahead and use either my commutative or associative property. And in this case, I'm going to do half of 16 is 8, and 8 times 6 is 48. And that gives me 48 units squared. Now, my favorite problem to do on this video is this one, because when you look at this figure, it can be overwhelming because there is no formula for area of a pentagon. However, what I can do is I can change it into a composite shape. I can find the area of this triangle up here and this trapezoid down here. And when I'm done, I can add those areas together. So if I take this triangle, it clearly has a base of 12 and a height of 6. So it's a triangle. The formula will be 1/2 base times height. My base is 12 and my height is 6. Half of 12 is 6. 6 times 6 is 36. So the area of the triangle is 36 units squared. So now I'm going to find the area of the trapezoid on the bottom. And the trapezoid follows the formula 1/2 the height times the sum of base 1 and base 2. And you'll notice that the bottom of that triangle is one of the two bases. And so I'm going to go ahead and recognize the base and the height always meet at a right angle. 1/2 times 5 times the sum of 12 and 6. And since 12 and 6 is 18, I'm going to multiply 1/2 times 5 times 18. This is, again, a great time to use the commutative property, and I'm going to reverse the order of the 5 and the 18 because I don't really like to work with fractions if I can avoid it. It's much more efficient to do half of 18 is 9. 9 times 5 is 45, which is 45 units squared. If I add the 45 and the 36, I get a total answer of, let me show you, 36 plus 45 gives me 81 units squared. Thank you for participating and watching my video on area. The last piece that I'd like to talk about is that area is used to show us how much space something occupies. When I look at these two rectangles, it's very clear that this rectangle is much larger, okay? It's actually a square, and it's much larger. In fact, if I was to find the area of this square, I would do 8 times 8 and get 64. To find the area of this rectangle, I would do 3 times 13 and get 39. So this clearly has a larger area. But what's interesting is if I was to add up all 4 of the outside edges, I'd get a 32 unit perimeter. And if I was to add up all 4 of these outside edges, I would also get a 32 perimeter. And so it's important for us to realize, although perimeter is a great measure, it's not a great measure for comparing how large something is. It can give you relative size, but area is a much better measure. The area of a polygon is the amount of surface it covers, or the number of unit squares contained within it, and you'll use it your whole life in trying to determine which is larger. Thank you very much for sticking around till the end.